Good morning, good afternoon, good evening, wherever you are. Welcome to another episode of Graph Hunter, Frameworks of the Mind. It's great, everyone, to see so many of the folks come back for episode 2. Thank you so much, and we have some new people as well. So let's jump in. Again, just some intros. I'm Corey Summers, CMO of ArangoDB, and Martin, why don't you go introduce yourself quickly?
Hi, everybody. Thanks for joining again. So my name is Martin Kovar. I'm product manager and I work for Cogniware.
Great. Thank you, Martin. Great to have you. So what are we going to do? We'll quickly recap episode 1. And for those that missed episode 1, but we're going to get right in fast to the design principles around Argos. We're going to then talk a lot about how the LLM integration is done very specifically, in fact, at a rather technical level. So for those of you who are interested in the technology, interested in things like vector store RAG versus graph RAG, we are going to really peel back the onion on that, which is exciting. And so for those of you that are really thinking about the pros and cons of that, we will do that and talk about it. And then we'll look at some conclusions and talk about our next episode. So Martin, why don't you tell us a little bit about Cogniware?
Sure, pleasure. So for the people who didn't join last time, we're a Czech-based company in the Central Europe. We're on the market for more than 10 years. And the core of our operation is to provide consultation services and solutions for digital investigation. We are doing this for both commercial sector and government sector. We have worldwide presence, and we have more than 100 projects already done worldwide in the field of intelligence, law enforcement agencies, financial investigations, commercial security, information breaches, and so on. So this is our core domain. And in order to do that, we developed our own software solution, which is called Argos. So maybe let me introduce you the software tool, which is the primary business of ours for now.
I did want to ask one question here, Martin. In terms of Argus being applicable to many other use cases, we talked about this in episode 1. It's just not, it's not just crime fighting, right?
It's definitely not just crime fighting. It has applications in the commercial sector as well, as we discussed last time. So supply chain management and spotting some irregularities and anomalies in behaviors of your suppliers. When you're evaluating security inside your organization, for example, you're issuing tenders, you want to ensure there's no conflict of interest of people involved in those hugely important decisions. So these are just ideas how to use our software and our services. We focus on analyzing any suspicious activities. It doesn't need to rely on the criminal activity only, but on the illicit activities and that pass to commercial sector as well.
Yeah, that's great. And in our next episode, we will be doing an in-depth demo and use case of Argus. But again, today is really around the technology choices you made on the specific integration, how the LLM and graph and knowledge graph work together. Tell us quickly a little more about Argus and how we work, or how you work with Arango.
Yeah, so for all the audience, I recommend the last recording of our webinar series because we explained Argos, our software solution, in quite detail. But in a nutshell, Argos is data analytics and investigation tool that is analyzing structured, unstructured content from internal or external sources and exposes to non-technical business users interface, which is able to query data very effectively and easily. So you can get answers to questions that relates to your investigative subjects, that uncover relationships that might be suspicious, that uncover the timeline behaviors, that focuses on confirming if one person knows each other with the other person, who are the people in the nearest neighborhood of one specific subject. So this is really investigation software, which is covering intel cycle from start to end. and it is built on top of ArangoDB. So we are putting like application logic, business logic, security measures, and very nice visuals and user interface on top of ArangoDB.
And Martin, one thing I love about Argus is the richness of the interface. It's really impressive. And I invite people to take a closer look at that. One thing I did want to ask you here is one of the use cases that people are very excited about is fraud detection. Is that something that could be potentially used here, financial investigations and so forth?
Yeah, Argos is domain independent. We are investigating suspicious relationship and suspicious transactional behavior, no matter of the domain. And banking and insurance is just one of these domains that could be easily applicable to the solution. So financial fraud is definitely one of the key use cases that we are dealing with. Although the product features are still the same, the only thing that changes is the underlying data model. But other than that, all the capabilities of our software enable to solve some such suspicious relationships and suspicious behavior with no extra effort.
Yeah, that's exciting because again, the value here with Argus is, you have very rich functionality, but people don't have to build that from scratch. And I suspect you can embed this as well. So that's really great. We're going to get into later what is it about Arango that led you to decide on that, right? Some of the capabilities of Arango that are unique in the market. So we'll talk about that again at a very deep technical level. Just to get everyone going here on Arango's side, right? If you look at our comprehensive product strategy, we have our multi-model graph database, and we talk a lot about this, and we're proud of it. It is the number one reason why people select us is the multi-model graph, document, full text search, geospatial, key value, whatever you need is in one platform. But as we'll see later, doing all of those in many cases better than standalone solutions. The value, of course, being the integration that you get out of the box on one platform. We have all these use cases, and we're seeing one example here, which is so exciting, and we'll get into that. This is really the new development, and we've had a lot of these capabilities for some time, but we're packaging them up in a unique way in our ArangoDB data science suite. So if you look at the original graph query capability, we have a powerful analytics stack there, GraphML, which is really around the predictive, and then on top of it, the Gen AI, the natural language, the LLM, the graph RAG, all that stuff. Now, Martin, I know you're using the Gen AI piece, but what about GraphML?
Yeah, actually, we took the road you just described. So previously we had a variety of technologies in the place. We use different technologies for full text. We use different technology for geospatial queries and so on. So the first step for us, and really good step, was to introduce ArangoDB as a multi-model graph database. But we are long-term users of ArangoDB, and we tried a lot of features over time. We started with graph analytics. So this was like the natural progression on top of traversal. So graph traversal was like the essential functionality that we needed to be able to query all the data for various questions like geospatial, full text, relational, and time questions. Graph analytics was great because it enabled like community detection, clustering of data, computing social network analysis metric like centrality, betweenness, PageRank, and so on. So this was great. But GraphML was really like the next extra step to introduce predictions and anomaly detections. So yeah, actually we are trying to cover all the possibilities of Arango, and whenever there is a new feature in the suite, we are trying to incorporate it as soon as possible. And for anomaly detection and prediction, I think graph structure is the best one, and we are very happy that it's built in the technology straight away. We don't need to develop it on our own.
So we had a
Yeah,
question come through. They're asking the Graph Analytics, GraphML, Gen AI. Is that part of the database or is this an add-on?
So great question there. The graph query is built into the database. Some of the analytics are built in, but some of the more advanced analytics, GraphML, Gen AI, and again, this Gen AI is really exciting because it's the pre-packaged API pack, if you will, integration pack that makes this very simple through the Jupyter notebooks. I invite you to, we'll have another webinar on this, but if you'd like a personalized demo, it is a guidepost on not just the GraphML, but the Gen AI. So yes, that data science suite is an add-on on top of your core Arango database. Of course, if you are an existing Arango customer, there is some preferred pricing, if you will, for that. So yeah, if you need a demo of our data science suite, we can set that up 30 minutes. Very exciting to see the time to market. That's the key, Michael, is the time to market of getting that. It's not months to get your data science implemented. It is a matter of days or a week or 10 days to get that going. So very exciting there. Thanks for that question. And then we have the visualizer on top. Again, this is a kind of a basic visualizer to navigate your graph. I know, Michael, you're the point guy on that, but what you're seeing today is obviously a bespoke application that adds so much more value. So, Martin, real quick on this, before we get into the technology in just a minute, what I'm excited about is how this really opens up. You have this user interface that people can click around on, and that's good for the technical, but for the business analyst, that's what this natural language will open. Is that right?
Yeah, exactly. So we were thinking how to make it even more easy for users, even easier to use. Don't get me wrong, our application is built, or user interface is built for non-technical user. It has specific screens for specific tasks. So again, look at previous episode. I think we described it quite well. What are the capabilities? However, there are still people who think, and especially investigators and analysts, they have their own questions already in their head. And what is the best interface how to ask those questions is just to type them, or use voice to represent them. But the question in written form is usually the first thing what you have. So
Yeah.
we were thinking, okay, we have large language models, how to make this transition, how to use conversational interface as a complementary to what we have already. It's not a replacement. It needs to
Yeah.
work, together. So
No, it's exciting, and the speed with which you can add this to existing applications is a key message.
yeah.
Now let's get into some of this. I know that there are two kind of pieces to what you're doing. There's structured graph data, and there's textual documents, both of which can be obviously stored and much more in Arango. Can you give me, I think people know about the graph side. What is an example of textual in your application?
Yeah. So the textual content, as it's a lot of data on the OSINT, so open source intelligence. It might be social media posts, but most of the time related to the nature of our clients, these are textual reports, intel reports, witness statements, or documents that are from digital forensics. So a long text which need to have to be represented, and we need to ask questions about those contents inside the documents. And of course, we need to correlate them together with the structured data. That's the important piece. And this is why we think that storing them in ArangoDB actually makes a good. It seems to be a good option for us because we don't need to use multiple storage technologies, and it's much easier to query them because of the full embedded full text engine. So it makes absolute sense for us to centralize this in ArangoDB.
And they could be PDFs even?
It can be anything. It can be Word documents, PDF documents. It can be even scanned PDF documents. So we have a processing pipeline in which we incorporate the OCR. So we transform the images into text, and then we store them in ArangoDB.
Very good. Um, what were the key, real quick here, Martin, what were some of the key design principles as it relates to LLMs and RAG and so forth? We'll get into more detail on these, I know.
Yeah, we tackled that last time. So the first thing, large language models, really nice topic, but the problem is we have our own data in ArangoDB already. We have the knowledge graphs. I don't want to use pre-trained knowledge. So this was like the core idea about this. And we wanted to use LLMs only just conversational interface for our ArangoDB. We don't want to use the pre-trained knowledge of that models. All right, so we have the JSON response from ArangoDB, and we want to just rephrase the results somehow. We want to understand the question and use it to build a query. That's the main idea of our solution right now. We don't want to rely on the data and the knowledge of the large language model because of the changing nature of the data.
Right, good. Tell us, get into some of the detail here, and we'll get into even more in a moment.
Yeah, so this core idea has a name. Okay, it's called retrieval augmented generation. So basically what we are doing, we are taking the user question as was suggested in the previous slide. So who are the people that were involved in the investigation for robberies from period of time and so on. So we want to transform this into the ArangoDB query with AQL. We want to query, fetch the data from the Arango and represent the results with natural language. And we use RAG, retrieval augmented generation, for that. So that's the concept. Now, there are multiple different techniques and solutions how to do this. We are using standard libraries like LangChain to standardize the procedure. And by the way, you've been mentioning the GenAI toolkit, right, from ArangoDB. And this is what we use to kickstart our efforts. So we use that LangChain agent that has been provided by you, and we used it to start exploring the ideas of transforming the queries into the AQL.
Yeah, that's great. And this is about the time to market, folks, where we can get this LangChain agent is doing a lot of heavy lifting that you don't need to do, right?
That's right.
Yeah.
That's right.
Let's get into the architecture. So reliable RAG and Argos.
So in Argos, Cognivare Argos tool, we have standard 3-tier application layers. So we have ArangoDB as a document store at the very bottom. And on top of that, we have some business logic where we evaluate security. We have dynamic security policies, okay? And especially in law enforcement and intelligence and military, this is like #1 priority to keep the data really secure. So we have dynamic security evaluations. We have auditing on top of that. So we know exactly which person asked which question, what kind of data are retrieved for which queries, and so on. We have a ways how to create a virtual graph structures out of ArangoDB. So each question requires different types of queries and different types of representation of the results. We have something that we call shortcuts, which are simplifying the graph structure for specific questions. We have also established some model typing and restrictions like integrity constraints and so on top of graph structure. Because in ArangoDB, we have a JSON store. However, we wanted to establish some standardization across the whole organization. So we needed to introduce some ontology and schemas that will be somehow strict to that. So when one of the users asks a question, we need to ensure that the same answer will be provided across the organization to other people as well. So on top of that, we are exposing APIs. We're not exposing AQL to our end user. This is a little bit different approach than some people are choosing, but we have a REST API for everything, and we are wrapping the business logic with the AQLs in that. And this is the place where we actually are using RAG because we have user interface with these nice visuals, network chart visualizers, maps, and so on, specific screens. And we wanted to have a special like assistant panel in there that would be communicating with the API somehow via the large language model capabilities. So this is where we have this blue circle or blue rectangle called RAG, And basically RAG is augmenting data using our API. That's the whole key point. Now, if we want to go a bit deeper, I will explain what are the options of the RAG. But to point it here, we have also some specifics which you normally don't see in the demonstration. So we have a conversation history implemented. We have a lot of instruction sets implemented here in the architecture that comes from model typing. We need to explain the structure of ArangoDB graphs to the large language model so we can have the better representation of either the questions or the results.
Yeah, and it seems to me this is all about the quality of the response, the consistency of the response.
Yeah.
The usability really comes from this.
Correct.
Yeah. Let's get into kind of the levels of RAG, and I put this together. I'm kind of proud of it. I hope it simplifies things, but we've got the normal LLM. There's no RAG there, right? Standard. I think this was the public trained knowledge domain, right, that you referred to. And then we have the vector store RAG, and you're going to get into a lot of detail here, but the LLM answers are augmented by private data sets, standard queries or keyword searches on vector stores. And there is some, in the context of knowledge graphs, there are probably more negatives than positives here, but I'm sure it's a religious war. We'll talk about that. And then graph RAG, right? So more complete responses. This is one of the biggest differences, Martin, that I see, is when you look at the depth of response of graph RAG, because it has the inherent relationships and the inherent context, it's far more detailed and bringing in, and this is the key differentiator for ArangoDB folks, is right, not just the graph, but you want the document, you want the geospatial, you want the full text search. That's what gets you the depth of response even deeper than other graph RAG. So would you agree here?
I would definitely agree. And there are like 2 points of view. So first of all, we started with graph RAG in the first place because we were thinking about how to simplify querying on top of structured data. Okay, so we had those government registries and vehicle registries and internal databases, which were already in Arango. And we just wanted to translate the natural language into AQL and retrieve the results. So we actually started with graph RAG. But then we were thinking about unstructured documents. And then this story starts to unfold. So first, we immediately go for the vector store RAG. We completely discarded the idea of no RAG because of all the reasons that I put last time: security, up-to-date information, missing knowledge, and so on. So we start for unstructured documents. We started to use vector RAG store or vector RAG. So this technology is like the primary. Nobody knows of using graphs for RAG in terms of unstructured content. At least it seemed to me from the very start. So yeah, so what we did, okay, how it works. You have long documents. You chunk them, so you split them into smaller pieces. Now you're using embeddings engine. You can use large language model, again, different neural networks that would create mathematical representation of these small chunks of texts. You store these numbers in a vector store. Now, then you have a question about some content. So who are people mentioned in those 2 documents? And what you do is you actually translate this question again to the mathematical vector, and then you do vector comparisons. You select like top 10 or top 20 chunks of text that are the closest to the question. You combine them together, you translate them back to text, and you feed it to large language model to use this as part of context to be able to represent or to be able to answer for this. It looks really nice. It is a nice idea, but it has a lot of drawbacks. There are certain issues with context window size, at least for now. Okay, this is June 2024. I cannot guarantee that the technology will shift in the future somewhere. But right now, we have a big problem with context window size. So you cannot fit all the information in the limited size that the large language model can actually handle. That's one of the biggest problems. Second problem is referencing the sources. Okay, I cannot trust the large language model to represent the result and to answer those results 100%. And there might be some other issues like missing related knowledge, having some abstract thinking about those concepts. So that made us thinking, okay, how to overcome these issues. And we had it, we had it from the start. We were using ArangoDB to query the data anyway. So we thought, why not to go for GraphRag? Why not to, again, take those unstructured documents? Why not to split them? But instead of transforming them into mathematical representation, why not extract entities and relationship from them and store them in ArangoDB, just as we do with the structured data? We have the graph traversal queries already embedded. We worked on that in the structured world. So we knew how to translate natural language into AQL. So this actually only required from us to use a specific library for extracting entities and links from the text. And then, it's perfect because it has a lot of benefits. We are not focusing on context window size of the large language models. We can work with really huge documents for this. We don't need to rely on some limitations. I need to be honest. It's a bit more expensive operation. It will take some time because you need to basically transform text into the graph somehow. So this might take some effort, but the benefits are, for me, it's worth to do so.
So let's get into that a little bit. The specific GraphRag. So this is like a blow up or a drill into of one piece that you showed us before. Is that right?
That's right. The concept is still the same. And it's actually combining those two approaches of having structured world and unstructured world fed into ArangoDB. So if you look at the right side, the internal source DB, using ETLs, we are populating the graph. On the other hand, we have documents. We have information extractor chains. Again, we can use the vector store as well, but we are fading away from that and we are feeding the data directly to ArangoDB. And from here, we just ask questions in natural language. We are using the LangChain chains connected to large language models, incorporated with some instructions. This helps us to translate it into database query. We query Arango for precise results, and we take those results and we let LLM to represent those results. And as I will show you in the next slide, we have source references. We are no limits on context window size. And actually, I've been talking about this from the beginning. We are not replacing the current application. We are just enhancing it. So we can use the same visuals as we are having right now to represent the results the same way. Plus, I have the textual representation. Right? So that's a great combination how to actually blend these two worlds together.
Again, folks, as we get into the deeper pieces here, if you have questions, please ask them along the way, and Martin can address them, or maybe I could, probably not. So even more detail, tell us about how the GraphRag works at an even deeper level.
Yeah, so this is just example of what I've just described. So imagine you have a really long PDF document, and one of the paragraphs or chunks of these documents might be talking about me working for a Cogniware company, and that Cogniware is offering Argos tool, which is using ArangoDB as one of its core components. Okay, this might be embedded in the text. So in GraphRag, how it works, we're actually using large language models or statistical libraries. There's a variety choice how to do that, to actually create a graph structure that we know from ArangoDB. So there are entities and links between those entities, and each of the entity might have JSON representation of the attributes associated. So I have Martin Kovar, which might be of a type person. I have a Cogniware, which might be of a type company. I have Argos, which might be, again, of a type like commercial product. ArangoDB, again, commercial product. And I have links between them. So I have Arango is used by Argos, or Argos uses Arango. Martin works for Cogniware, and so on. So this is typical ArangoDB storage. Now, on the other hand, I have user questions. So how is Martin Kovar related to ArangoDB? I will use, again, large language model to create me a QL, or the prompt to my database. And it will query Arango. So no matter of the size of the original content, it will return me the results in the form of graph. And I will, again, use large language model to represent those JSON responses. And now here is the good part. I can rephrase it in a sentence where Martin Kovar is indirectly related to ArangoDB through his work at Cogniware. And now I can reference the relationships because I have, specific information which is structured already. And what is great, for each link, so for example, if I have link between Martin and Cogniware, I can put reference to the original document chunks, right? So I know exactly from which part of the long documents I have this information. And this is one of the vital benefits of this approach, because you can trust the data by this. So you can put citations or references to your actual source data.
It's interesting because with our integration pack so that we can answer any question off the graph, there is a little bit of training that we have to do with the LLM for the AQL. Are you having to do that, or is it even more sophisticated with yours?
Yeah, so we are using set of instructions, and we are teaching, or not teaching, we are explaining large language model how our structure works. So we're telling what are the in the architecture. That was why we had those instruction set and integrity constraints and data modeling, because we can explain all the entity types and all the link types that are available in our data model to provide more explanation about how to represent the data and how to translate it into the query.
So within the context of your application, you could ask any question pretty much, yeah? And it will automatically generate the AQL.
Exactly.
So let's net it out when we look at this, the question, what are the top 10 crime types in the data? I mean, let's net out the difference.
Right, so especially when you're dealing with unstructured content, you have these options. Vector store RAG, which is a typical text embeddings. Most of the people are using this way right now. Or you can choose to use GraphRag. The difference is obvious. With GraphRag, you're structuring all the information in a graph database. Whether in vector store, you're creating mathematical representation of the text. The problem with the vector store is that it really needs to, if you have longer texts, you need to chunk them. And if you ask a question, it's basically doing a probability matching of those chunks to your query. Now, if the query you're asking is not specifically referencing those important chunks of text in the original documents, you will never receive correct answers because the large language model is working with different context. You're not feeding the large language model with proper information. Now, that's why this is not precise sometimes. Okay, that's why GraphRag is much more precise because it can handle much more sophisticated queries. Oh, also what it can do, it can abstract. So if the information are written in a bit different way, the GraphRag can use the graph structures and traversals to actually retrieve similar types of information and feed the content much more precise. So I think like in terms of size of the information you want to process, GraphRag is much more efficient and vector store RAG will fail. So imagine you have really like 10 to 100 pages documents. Vector store RAG is not enough because you will never feed the LLM with all the information. With a GraphRag, you actually can ask very specific questions. you can use community detection. You can use, similar traversals. So, and for me, one of the biggest things is that you can reference the source information.
If we look at the application and we link them back to Arango, right? Accuracy, scalability, security, user-centric design being the key ones there. Quickly, let's talk about accuracy, and then we'll talk about my favorite, scalability.
Yeah, I won't take much time of this because I explained it already. If you have graph rag, if you have graph structure, and you can translate the query into the graph question, it's easy because you can always reference it in the graph structure. You know exactly why the system answered that way. And for this, we are using prompt engineering tactics. We are instructing the models to be, to act in boundaries and to represent only the data that are fed from the ArangoDB. And also we have like temperature parameter for the large language model not to be too creative. And there are a lot of different techniques like user feedback loops where we actually standardize the question of the users. Okay? That's the tricky one because everybody can ask a different way. Sometimes you need to have the skills how to ask properly the large language model. We are somehow bypassing this by normalizing the queries.
Excellent. All right, this is my favorite, right? It seems to me, Martin, that if you're doing GraphRag, you need a highly scalable platform to match the vector store. We know it's more complete, we know it's more flexible, we know it's deeper, more context and richer, but we have to perform. And the key message of this slide is that ArangoDB has a huge advantage, exponential advantage on the scalability side, especially the horizontal scalability with the smart sharding, if you will. And this is unique, right? This is unique to Arango in the graph world. If you have all of this, and this is key to GraphRag, I'm sure, if you're looking at your cluster, you're going to have data that's, initially without smart sharding, it's got these connections across the nodes of your cluster. And this is problematic when it looks to network traffic and joining across here and searching across here. And I'm sure doing your RAG here, it's going to be a problem. And this is just the way it is default. And what you have with other solutions is you would have to manually, to overcome this, you would have to somehow, and I don't even know, Martin, how you could do this in a graph. I know you could do it in a legacy, and you're going to mention this, a relational model. You can put tables, group tables across nodes in a cluster, but here it's much harder because of the nature of graph with your vertices and edges and that kind of thing. So what we're doing, which again is not this manual sharding, which I don't know that you could even do in a graph environment, but we're going to automatically group the right nodes to minimize the network traffic, to minimize that. And that translates into cost, I assume, Martin, right? If you are doing this, it's going to take less time. It's going to be less expensive.
A lot of our clients, they don't know NoSQL databases or graph databases that much. They're stuck in the legacy world of relational databases. And one of their top question is, how is this scalable? Okay, where is the limit of the data where we can go, and how this affects performance? Now, if I always say that, graph traversal queries in relational world, they're too expensive. You cannot have this. You need to have different technology, but there's worrying about the scalability. But from what I see in this slide, this seems to be no issue, right?
Yeah, so this is a key thing, folks. If you're looking to have true horizontal scalability that's lights out, that's not manual, that's fully automated, this is a big thing that our customers look at, and this is why we're getting the performance, huge performance gains. We're going to be coming out with some interesting data soon on this, but I'm excited about it. Real quick on the security, you look at all the things in ArangoDB security there, which is quite robust. There are several that you're using the most, yes?
That's correct. So first of all, we've been discussing this last time. Local large language models, we cannot use ChatGPT like in the cloud. Okay, needs to be really protected. And again, a lot of people and IT operation people from our clients are asking about security of our database. And I think what really shines always is encryption at rest. This is something that we can encrypt the data even on the hard disk. This has been like the fancy feature that we've always using, and encryption in transit, of course. But the security in general, I think this is like top priority in all means. But these two, if I need to pinpoint something specific, is really the most vital one.
And then finally, the user-centric thing, which is so central to your and so elegant with the Argus.
I'm so excited for the next episode because we will be showing this in more broader context. However, I explained it already. We just need to blend in the current application. We don't want to have just textual interface. It needs to be somehow blended together. And we are using different widgets to represent different set of results. So for geospatial queries, we want to visualize maps. For timeline queries, we want to use obviously timelines and histograms. For graph queries, we want to use network chart visualization and so on. So we want to embed this into the application and use nice visuals and easy to use visuals for our clients.
This is great because, again, the fact that you can embed this easily is really nice. Let's get into our episode preview for our next show, Showcase of Shadows, and then we'll open up for Q&A. This is great because now we're going to get into the actual demonstration, the use case, the demo. I'm excited about this because this is the culmination. And then the next episode, after that, we'll get into even deeper architecture. But that we're going to uncover the Argus, right, in real time.
Super excited.
All right, let's do and see if we have some chat questions here. Here's a question. Imagine our systems work on relational databases only. How do I have to imagine how Argus would be implemented in such a system? Do we have to switch to ArangoDB as well, or can we combine it? I'll let you answer that. I do know we have simple migration tools that, because all of our customers at one point were in relational, and they had to go to graph. What is your experience with that?
Yeah, graph databases are quite new technology, I would say. I know it has been here for quite some time, but in those types of clients that we have, they stick with relational. For some queries, we are able to do external lookups, but to be completely honest with you, some graph traversal queries require a different set of technologies to be able to answer those questions in the performance that is required. So you cannot do multiple joins in the relational database, and especially for fine path algorithms, this is the most obvious one. You cannot achieve similar results only with the relational database. This is exactly why we decided to choose the graph storage and graph database to have answers for those questions really quickly. Now, we know that there is no need to move data from a relational database when there are no relations. Okay, it's a funny thing about linguistics. Like, it's called relational database, but graph database is much more effective for relational queries. So we can do the lookups for relational database, but we want to migrate the data into the graph storage for better performance and better graph traversals, and doing all the predictions and community detections and graph algorithms.
I have heard, and maybe it's related to vector store, but I don't think it is. I have heard people try to simulate a graph using a relational or document database by putting it into memory or something. Have you heard of that, Martin?
Yeah, but long term, it never works. This is cheating, it's cheating, and it has some trade-offs. And those, you're misusing the technology for wrong purpose. And graph database has been built specifically to do graph traversals and expose more complex relationships, which you effectively cannot do with relational database. It can achieve certain level, but once you start scaling your data and you have some performance requirements, this will fail. And basically, you start mimicking those graph structures in relational world. Not working for me.
Yeah. You know, our CTO, Frank Seller, has written an incredible paper available on our website on how to do or get started with that migration. So I recommend that piece. We also have like a quick start that we can help you with to migrate, do a proof of concept easily and quickly to show you the difference in performance, obviously richness, networked data, interconnected data. Yeah, Ray says connections in the graphs are made at creation time, relational at query time. No hope on that. That's funny. Yeah.
100%. Yes. Yes. We have our experiences with comparing different set of technologies in the previous one. We ended up in graph. Yeah.
Would you say, Martin, that graph has crossed the chasm? Do you think it's in the mainstream now, or it's still yet to be discovered by many people?
We live in the bubble, to be honest. Okay, we have this embedded in our product for quite some time, and we tend to think that all people are using it as well. But to be honest, it's still the legacy relational database are still on the market and still for this purpose like misused. I hope it will get better and better over time, because there are different set of technologies for different, like to store vectors, mathematical representations, you have vector databases. Okay, but for graph, you need to use the technology that has been specifically built for that. So, why not to use better technologies for that?
Yeah, well, again, Martin, great episode. I love how we went deeper this time, obviously, than last time. We'll get even more interesting as we go through the Graph Hunter series. It was great to see so many of you here, and we will see you on the next episode of Graph Hunter. Can't wait for that episode, Martin. Thank you so much.
Thank you so much, Corey. Thank you, everybody. Have a nice day.